Okay, good day. This is Math 140 College Algebra. I'm Professor McCulley. This is lesson 5-6 on polynomial regression. Let's get right to it. Today we're going to create a polynomial model based on the data, and then we're going to use a created polynomial model to make future predictions. We have already done linear regression in this class, and we talked about the correlation coefficient and the eyeball test, and just again, the eyeball test isn't a great method, and it's certainly not something that you would use in a formal paper, but it is certainly a tool that you can use to get started. And so if I saw a bunch of data, even though it kind of looks random here off to the side, if I looked at that data there, I noticed that it kind of goes up and then eventually kind of comes down. And so I might want to use a quadratic model for something like that. All right. Now, if my data looked a little bit different than that, let's say as a for instance, my data did something like this. Maybe we'll throw a few more in there. I might, in that particular instance, say, all right, let's see, there's a it kind of looks like that maybe. And I might use a cubic model for that particular data. So using the eyeball test definitely gets us started. And then through other methods that you might learn in a more advanced course, um, you might be able to verify your decision a little bit better. All right, so let's review these steps for regression. So the first thing you're always going to want to do is clear your data, and you do that by hitting stat and then clear list. You're going to enter your new data by hitting stat and then edit. You're going to graph that data in a scatter plot, and that will allow you to do your eyeball test. And so you're going to second Y and then turn it to on. Set an appropriate window by hitting second and then the window button. Actually, I don't think you need to hit second. You just need to hit the window button. We're going to decide on the appropriate model, whether it's linear, cubic, or quadratic, etc. We're going to complete the regression, which is stat, calculate, and then we'll hit the menu. All right, and then go over to the calculate menu. Then we're going to graph the resulting model to check it. So when we're talking about linear regression, we had a correlation coefficient, which is a measure on how close the regression curve is to the data. Whereas in this one, we're going to talk about R squared, and R squared is the portion of the variance that the dependent variable is explained by the independent variable. All right, so it's going to be kind of a ratio. It's going to be between 0 and 1. Sometimes it's written as a percent. All right, so let's see here. Use the following set of data to create a quadratic regression equation. And so in this particular instance, they are telling us what we should use. And so we're going to go to our graphing calculator. We're going to clear, and then we're going to go through all the steps. So the first thing we got to do is we need to clear out the data. So we're going to hit the stat button, and we're going to hit the 4 for the clear list. And then we got to remember we're going to put the x values in L1. And then we're going to hit comma, which is right above the 7. And then we're going to hit second and then L2 to clear out the second list. All of that is done. And so now I'm going to hit the stat button and hit 1 for edit. And I'm going to go back over to that L1. And again, the data is presented horizontally, but we're going to enter it vertically. So 1, 2, 3, 4, 5, 6, 7, 8 in the x values. So 1, 2, 3, 4, 5, 6, 7, and then 8. And then we'll go over here, and it's 1, 4, 6, so I'll enter that 1, 4, 6, and then 7, 8, 6, 7, 8, and then 6, and then we had 5, and then 0. Okay. All right, so we want to take a look at this data. So I'm going to go second, I'm going to go stat plot. I'm going to hit 1 for the first stat plot. We want to turn that on X list was L1, Y list was L2. We're going to have little squares, and then we want to change the window. We don't need all of those negative X values, so I'm going to go -2, and then it goes up to 8 for the X values. And then similarly for the Y's, we don't have to worry about a whole lot, so we'll go from -2 up to 10. That looks good. And there is my scatter plot. And while, again, it's definitely not perfect, it does kind of look like it might be kind of quadratic-like. And we have the equation from the last one that we want to clear out. And so now we want to complete that regression. And so I'm going to hit Stat. I'm going to go over to Calculate. Now they told us to do a quadratic regression. So quadratic regression is number 5. We're going to hit Enter there. L1, L2, no frequency list. And then we want to store the quadratic equation. We're going to hit our vars. We're going to go over to y vars. We're going to hit function. We're going to hit 1, and it's going to put that equation into our graphing calculator for us. Hit enter, and we have this. All right, so the equation that we have is going to be y equals, and let's see here, my a value -0.55 or 565, so -0.565 x squared, because they told us it was quadratic, and then 5.077 plus 5.077x, and then finally our constant -3.803 plus 3.8, yeah, I think I messed that up. Let's check it again. 3.803. Okay, 0.803. It should have been a minus, though. I have a plus, so let's fix that real quick before we move forward. Hit minus. Now, if I did it correctly, and I hope I did, I hit y equals. There is all of the digits and entered in there, and so that's going to be slightly more accurate. When I hit graph, I have this nice curve that kind of fits my data fairly well. All right, got one more example here. Says the number of smartphones in millions of units sold in the USA is arranged in the table below. Using 2005 as t equal to 0, find a cubic regression for the model of the data and the corresponding r squared value. Okay, so if I quit out of this, I want to clear. So I'm going to hit Stat. I want to clear the list again, so second 1, comma, second 2, that clears out that list. Hit enter there. Now, stat, we want to edit. Now this time they said 2005 is 0, so this will be 0 here. This will be 1, 2, 3, 4, 5, 6, 7, 8, 9. So I gotta redo those. So 0, 1, 2, 3, 4, 5, 6, 7, 8, and then 9. Okay, so we're going to go over to our second list, and let's see here, 1.3, 2.6, 2.9. So 1.3, 2.6, 2.9. All right, go back over here. 3.1, 3.2, 3.3. 3.1, 3.2, 3.3, and I see that I forgot my decimal place right there, so I'll use my up arrow key to get in there, and now we'll go back down to this one. So my last three, 4.9, 7.8, 13.4, 4.9, 7.8, 4.9, 7.8, let's see here, 13.4, 18.6. 13.4. The last one, 18.6. Everything matches up, so we're looking good there. Hit that stat button, go over to calculate. Now we're going to do a cubic regression here. So I'm going to hit 6 for my cubic regression. We want to have all of that. And so we want to store the regression equation. So we're going to hit the vars button again. We're going to go over to yvars functions. We're going to hit y1 and it'll write over what we had for the last one. Hit enter to calculate. And we have all that, and our r squared here is 0.995. Ooh, so clearly my data has been doctored. I made it up. R squared equals 0.995. So they're saying that all of the variance of the almost all, 99.5% of the number of smartphones sold is explained by the year, and clearly that's not true. So my data is made up, and my equation y equals, well, let's write it down here. So 0.673, 0.0673 x to the third, and then it will be minus 0.556 x squared minus 0.556 x squared. I better check before I decide. Yep, it's plus 1.598 plus 1.598x, and then the last one was a plus 1.08 plus 1.408. That is my equation. So all of that is my A value. My B, how many smartphones were sold in 2008? All right. Well, if 2005 equals 0, then 2006 would be 1, and 2007 would be 2, 2008 would be 3, and then 2018 would be 10 years after that. So we're talking 13, right? Yeah, so 13 years. And so we are finding 13. So let's go to our equation here. Let's change our window so that we can actually get the 13. And so I'm going to put 15 there, and then it's probably going to go up pretty fast since it's a cubic equation after that. And if we look at the data, this last one was 18. So just to be on the safe side, I'm going to put 100 in just to be safe, and I'm not even sure that's going to be enough. We'll go 10s there. We'll hit our graph, and look at that. We're gonna look how nice that hits our data. And again, 0.995% of the variance is explained by this, so it should be pretty close. And if I want to figure out that 13, so second trace, we're going to do a value. We're going to type in 13. We're going to hit enter. So 77.551 million smartphones in 2018. That number's probably a little high, but that's okay. I just made up the data. Well, that's all I got for today, folks. So today's Marvel fun fact of the day: WandaVision is said to have sitcom inspirations from the various family TV shows from the 50s, 60s, 70s, 80s, and 90s. I saw this picture on the internet, so I pulled it up here. You've got a picture of Wanda and the Vision that looks similar to I Love Lucy's. You've got this wasn't Ward, June Cleaver from Leave It to Beaver in the 60s. You had Mrs. Brady from the Brady Bunch. You got Family Ties and Roseanne, and then Sabrina the Teenage Witch from the 90s. That'll be kind of crazy. Looking forward to seeing it. That's all I got. Bye.